All right, Algebra 2, we are going to keep graphing sine and cosine functions. So it will be most helpful if you have already printed off the homework for today, because we're just going to use half of the homework as our notes, and the other half you will get to finish for your homework assignment. So if you haven't already, go ahead and hit pause and go ahead and print off the homework, or you can grab your notebook and just write down the equations. Do write down the equation next to your graph. That helps me as I look at your work. But what we're going to do is we are going to graph at least 2 periods of each function, or 2 cycles of each function. And we want to make sure that we're scaling our axes correctly. So let's think about this graph right here. Y equals the sine of x. Remember, that's our parent function. Remember that the range of the sine function goes from 1 to -1. I'll try and make that look even. So from -1 to 1, that's our range. So we're going to scale our y-axis to reflect that. And then what is the period of the sine function? Well, remember that the period is 2 pi. So I'm going to come out here and mark 2 pi. And then I'm going to divide that into fourths so that I can plot those quarter points. So divide that in half and half again. And half of 2 pi is pi. So I'll label that as pi. 1 cycle will occur in that 2 pi radians. And I want 2 cycles, so I'm going to extend that scaling out to 4 pi. Now, does the sine function begin at a minimum, maximum, or 0? Well, the sine function begins at a 0. So I'm going to plot right here the 0. And remember, sine function will increase first. So at each of these quarter points, I will either be at a minimum, maximum, or 0. So I can graph this rather quickly. Maximum, 0, minimum, 0, and I'm going to bounce back and forth between that minimum and maximum for those quarter points of the sine function. And I could go backwards too. This would be negative pi. This would be down to 0. I'm sorry, -1, back to 0. And I could keep the sine function going forever because it's a periodic function. Those cycles would continue forever. Now, what we want to talk about today is how do we begin to transform the sine and the cosine curve? Now, the beautiful thing about mathematics is all of these transformations of functions use the same rules. So the same rules we were using way back at the beginning of the year of shifting vertically and horizontally still apply to trig functions. So take a look at number 2 here. I would like to graph y equals sine of x plus 3. Now notice this plus 3 is not inside the sine function. It occurs afterwards. So remember that that means to shift vertically up 3. That means this whole graph is going to shift up 3. What will that make the maximum? Well, the maximum was 1. If I shift that up 3, it now goes to 4. And the minimum was -1. Shifted up 3, that goes to 2. So I'm going to be bouncing between 2 and 4. Where will that midline be? Well, it was at the x-axis, but it will also go up 3. So here's how I handle that on the axes. I know that I have to have a maximum of 4. So I'm going to scale up to 4. And I'm going to label that 4. And then 2 is going to be my minimum. I'm going to label that as well. And halfway in between is that midline. That midline will always be halfway between your maximum and minimum. I do want you to draw it with a dotted line because that is where those 0 values these points right here will be. And so we want to mark that so we can see that midline. So everything is shifted up 3. Did the period length change? Not at all. So I am going to mark this here as 2 pi and 4 pi. Each of those is divided into fourths for the quarter points. So the scaling stays the same. We're really looking between 0 and 4 pi for 2 cycles of this. So we have the vertical axis set. We see the new midline. We see the new maximum, the new minimum, and the x coordinates and the scaling on the x-axis stay the same. So where does the sine function begin? Does it begin at a minimum, maximum, or 0? It begins at the 0. But the 0 is no longer at the origin. It was shifted up 3. So it begins on that midline. All of the zeros will be on that midline. And now at each consecutive quarter point, we'll follow and go up to a maximum, back to a 0 at that midline, down to a minimum. That minimum's at 2 now, back to a 0 at the midline. Maximum, minimum. 0, minimum, back to a 0. And here is the graph of y equals sine of x plus 3, shifting up and down. All right? What happens if I want to shift horizontally? Well, let's look here. You can see that that change occurred inside the parentheses, inside the sine function. So that designates that we have shifted horizontally. We have not shifted vertically, so my maximum will still be 1. My minimum will still be -1. Now here I am shifting, remember it's that opposite effect inside, so I am shifting to the right pi. Now I'm going to be nice to you in these horizontal shiftings. They are going to work nicely with the period length of the function since we're just beginning these. So I like to go ahead and put my quarter points on, just like I've scaled every other sine cosine function. So put these quarter points on, 3 pi, 4 pi, there we go. That's how we would normally scale it. But I have shifted to the right pi. So that means I'm starting here, I'm actually shifting to the right pi. I am going to draw a dotted line there. Now that is not a vertical asymptote. That is just showing the fact that I've shifted to the right pi. This is where I'm going to begin. It's like the new vertical axis. So when I think about the sine function beginning at a 0, like up here, the parent function begins at a 0. That 0 is actually going to occur here at pi because my dotted line is showing me my new vertical axis. Now I'm going to follow the quarter points and go to the maximum, 0, minimum, 0, maximum, 0. But I haven't quite graphed all a full 2 cycles. So I'm going to go backwards. I always like to incorporate that original y-axis. So I'm going to follow my pattern backwards. This would be here, and then it would be there. And so connect those with a nice smooth curve. And there is the graph of y equals the sine of the quantity x minus pi. It is the sine function shifted to the right pi. And you can tell that from that dotted line. So that's what we're looking at today. Those vertical shifts, if it's outside of the function, it's going to change the scaling on the y-axis. And those horizontal shifts, it's going to shift along that x-axis. Go ahead and turn, I'm going to let you do number 3 and 5 for homework. Let's just remind ourselves of what the cosine curve looks like as a parent function. So it also has a maximum of 1, a minimum of -1, because remember the cosine and sine are essentially the same except for where they begin. Period length is 2 pi. Mark it, cut that into quarters, and then extend that for another cycle so that we have 2 cycles of the cosine curve. Where does the cosine curve start? A minimum, maximum, or 0? Well, the sine function starts at 0, so it doesn't begin at a 0. It begins at the maximum of 1. And follow those quarter points. Minimum, 0. Maximum, 0. Minimum, 0. Maximum. And you could bring it backwards even to -pi or even further. The only difference between sine and cosine is where it begins. Cosine begins at a maximum. So on these examples here, what's happening? Cosine is shifting down 1. So if I'm scaling, I was going between -1 and 1. So everything's going down 1, which means I will bounce between -2 and 0. -2 will be my new minimum, and 0 will be my new maximum. And that midline gets shifted down at that -1. Went down 1. The period length stays the same. The scaling be great at coming up with quarter points. So where does the cosine begin? It begins at a maximum. Here's the 0 line. So the maximum will actually be at 0. Then I go down to the midline, minimum, 0, maximum, 0, minimum, 0, maximum. I have taken that cosine curve and shifted it down 1. These are all of the pieces that I want to see on your graph. I want to see the midline as a new dotted line. I want to see scaling on the vertical axis and on the horizontal axis. What will happen here? Well, we'll be shifting to the left pi. So the maximum stays at 1, the minimum stays at -1. I'm going to scale as normal to 2 pi and 4 pi, and then I will split those into quarters. So here's 1 pi, 2 pi, 3 pi, 4 pi. Sounds like a good Dr. Seuss book, something like that. But I am shifting to the left pi. I don't have any scaling over here, so I better throw some scaling in. Here's -pi. There's -2 pi. I'm shifting to the left pi. All right. So now cosine still starts at a maximum, but it's going to occur shifted to the left. So over here, it actually begins at that ordered pair -pi1. Then I've got all my quarter points, so I'm just going to follow the pattern in the points. Minimum 0, maximum 0, minimum 0, maximum 0, minimum. And you can take it backwards as well. Whoops. Sometimes my drawing's not quite so great. That's why it's important. I do want to see each of those points on the graph, because then if your curve does not actually hit all of those, I'll know what you meant to do. So same rules apply, vertical shifting, horizontal shifting. All right, last thing I want to look at, let's look at number 11. We want to be able to go the other way too. Can you write an equation for each graph? So let's look here. I would suggest drawing in the midline. Can you see it? It's going to be halfway between the maximum and the minimum. So that's halfway between 6 and 4. So that must be here at 5. So since the midline is up here at 5, I know I shifted vertically 5. I went up 5. And then take a look here. Notice I finished one cycle in 2 pi radians. That's good. And so what is that graph? Did I begin at a minimum, maximum, or 0? I began at a 0. So that's the sine function right there. That is the sine function shifted up 5. So plus 5. That is an equation for that graph. But guess what? That's not the only equation for that graph. I could have also thought of it right here. What if I think of a shift to the right pi over 2? Then I'm beginning at a maximum. Well, that's the cosine curve. So I could think of the cosine curve shifted to the right pi over 2. That'd be x minus pi over 2. But it is also still shifted up 5. That would be another equation. Well, what if I wanted to start over here at another 0? Well, I could do that as well. I could do y equals, that would start at a 0. That's the sine function. Shifted to the right 2 pi, but still shifted up 5. Ladies and gentlemen, there are infinitely many equations you could write for each curve, sine wave or cosine wave, or what we call a sinusoidal function. Isn't that a great word? Sinusoidal. So if I ask you to write one equation or two, I'm actually just asking you to scratch the surface of all infinitely many you could write. All right, so there we go. Shifting vertically, shifting horizontally. I think you've got it. What I'd like for you to do is go back and just finish those examples we didn't do. So you've got 4 graphs to do, numbers 3, 5, 8, and 10. And number 12, try to come up with 2 equations. See what you can do. Fill the page if you want. That'd be awesome too. So I look forward to seeing your work. Show me what you can do. Thank you.